Hi, this is Wanicho, and I'm studying Korean NLP in Seoul National University. Today I'm going to talk about the translation gender bias on the problem definition and why it matters. We will first briefly check in what area the phenomenon is significant and which struggles have been taken so far. Our approach towards this issue regards first the selection of language pairs and templates, and we construct the dataset, and then decide the measurement metric of fluency and biasness. Then we conclude our presentation with the analysis and takeaways. First, as many of the attendees may be familiar with, we deal with the bias issue in machine learning. In ML viewpoint, it is related to the issue of bias and variance, mainly regarding overfitting and underfitting. However, in view of fairness machine learning, since 2017 defined it as a problem of individuality and context rather than of statistic and system. Is the bias in machine learning related with the bias in fairness machine learning and real social bias? Considering the case of image semantic low labeling suggested in Zhao et al., we deem that all these concepts can be connected. For instance, the trained model labels the photo regarding its agent and content, while the inference is affected by the context of the photo, for example, the brightness, colorfulness, or hue. We can suspect that such inference not only comes from the trained data, but is also assumed to be aligned with the people's stereotype that female agents may be more fit with a colorful environment. This also happens in translation and other NLP tasks. In Sun et al., various tasks in NLP have been investigated for their potential representational bias. It includes two text generation tasks such as in translation, caption generation, and speech recognition. Also, the issue is displayed in sentiment analysis, language modeling, and word embedding, covering semantic and lexical aspects. It is notable that almost all text-related tasks concern the issue of stereotyping, and empty is the representative one. Let's get deeper into this. The first type of gender bias in translation is shown in gender-neutral pronouns, which can be referred to as singular they in English. While the singular they in English is yet widely used in colloquial context, despite their wide usage in the literature. In other languages, gender-neutral pronouns are frequently used in conversation to indicate someone without displaying his or her biological gender. In view of translation, this matters when the gender-neutral pronouns are translated to gender-specific ones. If there is no context available, this becomes the problem that shows the inductive bias of the trained model, as investigated in Price et al. With 12 languages. If there is any context that implies the actual gender, it becomes the problem of right and wrong. The second type of gender bias in translation is related to the grammatical gender of the languages. It is mainly shown among some Indo-European or Semitic languages, and the grammaticality is usually assigned for articles, nouns, or adjectives. It is distinguished with the biological gender of gender-specific pronouns such as she or he, but it is probable that mistranslation can be offensive as well for the end users. In Van Massenhoff et al., the issue has been scrutinized with the biased speaker distribution in translation corpora that affects gender assignment in the inference. Here is the overview and our aim of research. Why does translation gender bias matter? As the public empty modules are in service for almost everybody who has a will for the usage, the mistranslation can yield results that are offensive to end users. They matter in almost all the cases when the users are familiar or not with the target or source language. If they are familiar, then they might face direct harm by recognizing it. If not, they may have trouble in somewhere where the results are used and the error is implied. The harm may include severe offensiveness if the mistranslation regards any kind of social stereotypes, for instance, with occupations or judging terms. Our two research questions follow. How can the evaluation on such public empty modules incorporate various aspects of translation gender bias stated so far at a single evaluation? Next, how will the grammatical properties and research conditions of each language influence the bias issue? We introduced some evaluation trials by adversarial attacks. In Cho et al., The biasness of Korean to English translation was undertaken with a template-based approach that uses she or he is something, where something denotes occupation or sentiment words. The Korean was chosen since it incorporates various sentence styles and the translation service is quite popular among web users. With about thousands of the content words, 3 public empty modules were tested with a new suggested measurement that implies the biasness of the gender assignment. The results show that one of the tested modules display a biasness inference that is tilted to males, and others also display this stereotypical inference on occupations despite the relatively balanced result. We want to claim that one limitation of this kind of template attacks is that the evaluation can only check the biasness, not if the inference is correct. The other example is in Stanovsky et al., where the gender bias in from English translation was investigated for 8 languages. The correspondence of the article was checked with the co-reference dataset that includes semantic cues, and the evaluation was done with both accuracy and if the co-reference regards stereotypical or non-stereotypical inference. Beyond each public empty module's performance, it was also shown that the performance differs among a similar language family. And also the high accuracy in this stereotypical case does not necessarily guarantee the accuracy in the counterpart. We were inspired by the evaluation procedure of the 2 main approaches so far. Here we introduce how we combine the aforementioned approaches. 2 different types of translation gender bias was just suggested so far, but they had been sought for in different research projects usually. We note that both properties should be checked for a single translation system in view of real service that has end users. On choosing the language pairs of interest, we considered the following language groups. First, languages with gender-neutral pronouns have the least gender-related notations here, and also they do not show the grammatical gender. The second group is the languages without colloquially used gender-neutral pronouns while not showing the grammatical gender. The last one is the languages with grammatical gender, and also they rarely show colloquially used gender-neutral pronouns. We chose the languages of interest, namely Korean and Tagalog, English, and German and Portuguese, with the above grammatical criteria. In specific, Korean and Tagalog have GNPs, and German and Portuguese show gendered articles and non-derivation. However, there is another factor we considered. Though public empty modules are usually trained based on the language resources of their own, we deem that the used resources are directly or indirectly affected by the available open resources regarding each language. Since translation is inevitably a multilingual process, we need to fix a language that enables us to concentrate on the languages of interest. Here we call it a measure language. The language that is used as a fixed side of a pair, either as a target or source. Korean and Tagalog are used as a source language, and we need a target language to observe how the gender is specified in the translation process. Similarly, investigating German and Portuguese requires the source language that lets us to see how the grammaticality of the articles or nouns vary. This is the point we necessitated the measure language, here fixed as English. English is chosen for several reasons. First, they fit the condition of the second group language. Next, the amount of language resources in English is often dominant regardless of the specific language of interest. Thus, the amount of resources regarding to English or from English translation might tend to represent the resource condition of the source or target side of the pair, not English, and it enables us to compare between the language pairs, though the measure language is inevitably engaged in. We attached the opposite results for the availability of open resources, where we found German larger than Portuguese and Korean being larger than Tagalog in tokens. The next part is making up a template that can display each type of gender bias at the same time. Here, we added a clue to the template used in Cho et al. For Korean to English translation. The clue is the part provided for the coreference that is done at the second part of the sentence where inference happens. In all languages, the biological gender is suggested at the first part of the sentence, and the information should be reflected in the inference part unless some exceptional cases that the specific grammatical gender should come for the corresponding noun expression. In Korean on Tagalog to English, we see if the gender-neutral pronouns such as K or siya is translated properly considering the provided biological gender. In English to German or Portuguese, we see if the grammatical gender regarding article or noun is properly represented. A point to consider is that though this template simultaneously displays how the translation gender bias is shown in various language pairs, the shape or aspect of bias differs from type to type. However, the type of error does not hinder the potential harm of the failure of the inference. Thus, the errors regarding the type of language pairs will be evaluated equally as gender-related accuracy, regardless of how difficult the inference seems at the viewpoint of engineering. As we set the languages and the template, we made up the whole dataset by augmenting the content words into the template. Here we adopted the sentiment and occupation words used in Choerol and translated it to the languages of interest and the measure language. Making up the template for Tagalog and English, and also making up the gold standard for German and Portuguese, was supported by an automatic translation module for draft and was refined by the bilingual language specialist. 2 points were considered. First, since sentiment words for English to type to language translation should be noun words, we borrowed it from SentiWordNet to guarantee that 2 German or 2 Portuguese translation can include an inference regarding grammatical gender. Next, since the original word database may highly rely upon its cultural background, here Korean, the content words that are not appropriate for or not used in each language was removed in each translation phase. For instance, detailed military titles, which are well known in Korea due to its mandatory service, was not recommended to be utilized in other languages. Thus, those were considered in making up the final sentence set. Setting up specific evaluation criteria was also the main part of our approach. Since we utilize the inference result with public empty modules, the output can be in a quite different shape with the gold standard. Unlike in Type 1 to English translation, where the gender-related inference is only checked for the pronouns, this kind of inconsistency more matters in English to Type 2 translation, where the grammatical gender is fixed for some noun regardless of the biological gender of the agent, and even some articles are omitted for some cases. We set more specific guidelines for the human check. For instance, article omission for sentiment words in Portuguese or occupation words in German were checked OK. The above evaluation checks accuracy on biological gender and grammatical gender. Also, with regard to the biasness, we check the disparate impact, which is defined here as the accuracy of female cases divided by accuracy on male cases. Though we did not include the non-binary gender for the pronoun, we did not observe any output in English, German, or Portuguese on those cases. If they had appeared in the inference, the case would have been considered correct, since not preferring to state the gender does not necessarily cause explicit harm, compared to the case that the gender is wrongly inferred. Though not the main goal investigated here, we also need to check if the fluency of the translation is acceptable. Though the translation direction differs from each other between language pair types, we saw that the metrics such as BLEU and BUD score can lawfully show the translation quality, both in lexical and semantic viewpoint. The evaluation was done in several aspects. First, for per system, where the system implies each public empty modules, namely Yandex, Bing, and AWS, the evaluation was done for each language pair with templates and measurements stated previously. We observed that Korean and Tagalog to English cases tend to have lower fluency scores compared to the counterpart cases, while showing less biasness in the overall systems. The gender-related inference was shown almost all correct, except for Korean to English translation using Bing, and it was observed that various stereotypical bias was displayed regarding the wrong answers. For instance, occupation words like a cop or guard, and sentiment words such as cute, weak, and fragile, etc. This dramatically lowered the disparate impact of the case compared to the same circumstance in other systems. For Type 2 languages, it was exhibited in general that more gender-related errors are shown in German compared to Portuguese. The error was more significant for female cases, and it also lowered the disparate impact. We took a further analysis to find where these different per-language pairs come from. We aggregated the results per system and made it into per-language comparison. Here, unbiasedness score means the total gender-related accuracy, which is differently evaluated per pair, but can be similarly offensive to end users. We've checked that unbiasedness is more guaranteed in the language with less resource available for the same type of language pair. Korean being more biased than Portuguese seems to be due to a single outlier case. We could find a similar tendency for disparate impact where German showed the lowest. Also, given that the Type 1 languages have a lower amount of resources overall compared to the Type 2 languages, it can be inferred that more resources might have contributed to the amplification of stereotype-related coreference errors. We noted that this kind of unbiasedness factors tend to have some negative or positive relationships between the fluency measurement. First, blue, which represents the lexical similarity of the predicted sentence with the gold standard, was observed to have a high discordance with the unbiasedness. Since gender-related inference occupies a small portion in the whole template sentence, it seems that the errors in such factors were overlooked. Also, it is plausible that high-resourced languages have a high blue score. However, we found that BERT scores show a slightly different distribution. Though the absolute values are not that different, Tagalog displaying the high score tells us that BERT score can point out the appropriateness of gender-related inference than Blue can do. This yields two observations. First, the amount of available language resources, though here assumed for public empty modules, does not guarantee unbiased translation, albeit fluency may be higher in some sense. And next, there is a difference regarding the evaluation on gender-related inference per fluency measures, here represented with blue and BERT score. And we think this can be considered as a future strategy for AI text check in machine translation systems. Now, takeaways. Translation gender bias is problematic since wrong results can be offensive to end users. And translation gender bias matters regardless of the user proficiency of the language, and especially offensive if the mistranslation engages social stereotypes. In this sense, our approach, including template and measurement, can combine the translation gender bias evaluation shown in various language pairs. And as a consequence, our results suggest that the indicative bias as a social stereotype is a major factor causing the errors, and augmenting training corpora may not be a solution to this issue. This is the end of our presentation. Thanks for listening.